Our lesson today was going over exponential functions and their different characteristics, determining whether a point is on the graph of the function, and then actually graphing these exponential functions. So I'm going to go through what our notes would be and then an example of what graphing an exponential function would look like. So first off, our parent function, remember that's our most basic function. Our parent function would be f of x equals b to the x, where b is the base and then x is the exponent. All right, for a growth function, we know it's a growth function if b is greater than 1. And what that would look like on a graph, just a quick sketch here, is it would look like it's going up. So I like to say you're going up the ski hill. So from left to right, you're going up the ski hill. It's a decay function if b, so your base, is in between 0 and 1. So it's a fraction or a decimal in between 0 and 1. So like 2/3, 1/4, 0.2, all of those would be decay functions. And what those look like is you're going down the ski hill. So just a rough sketch there. So growth is going up the ski hill, so you're taking the lift up to the top. Decay is you're going down the ski hill. And then an asymptote is where the graph approaches. So it's a line that the graph approaches but never touches. Okay, all exponentials have an asymptote, and I'll show you what that looks like on our graphing example. But first up, let's look at determine whether a point is on the graph of the function. So remember with our point that our first value is x, second value is y. Okay, y is also f of x, so you'll see f of x a lot. Remember that's really just a fancy way of saying y. So that means I'm going to plug in our point into our function right here and see if we get the same number on both sides of our equal sign. If we do, then it means that that point is on the graph of our function here. So if I plug this in, I know that y is 3, which is also f of x, and I know that x is 1. So I'm just going to plug in what I know. So I've got 3 for f of x equals 2 to the first power, because I said that x is 1, and then plus 1. Well, 3 equals 2 to the first power is 2, plus 1. 3 equals 3. So since it's the same number on both sides of our equal sign, it is a yes. So this point of 1, 3 does exist on the graph of our function. All right, moving on to graphing one of our exponential functions. I like to fill out a table. It helps me to keep track of where the points are, what I'm doing, how I can plug stuff in. I like to use the values of 3, -2, -1, 0, 1, 2, and 3. You can choose any values you want for x, does not matter. Make sure they're on the graph. So like here, -3 would be right here for x, -2, 1, 0, 1, 2, 3. I like to use these points because they're really easy to plug in. It means that my numbers usually don't get really big either. All right, so to plug these in, and I'll switch colors here, we said that x are these values, so I'm going to plug them into our function. So f of x equals 2 to the x is our function, so I'm going to plug those in. So it'll be 2 to the -3. Well, in order to find our y value, I'm just going to evaluate that. So 2 to the -3 gives me 1/8. Remember, if you have a negative exponent, that it turns it into a fraction. If you need to use a calculator on these, please do so. I use a calculator on all of the exponentials just to make sure that I have the right values. All right, well, I'll just go through filling out our table. So I've got 2 to the -2, so I'm plugging in this -2 in for x. And that gives me a 1/4. 2 to the -1 gives me a 1/2. 2 to the 0 gives me 1. 2 to the first power gives me 2. 2 to the second power gives me 4. And then 2 to the third power then gives me 8. All right, so now that I've got my points here, so my point makes up our x's and our f of x's. So remember, those are our y's. So I could rewrite all of our points. Say that -3, 1/8 for this function. -2, 1/4. -1, 1/2. 0, 1. 1, 2. 2, 4. And then 3, 8. So all of these points exist on our graph. So I'm just going to plot these really quick. And when there's fractions, just estimate. You're never going to get them perfectly on there, totally fine. So -3, 1/8, I'm guessing will be about there. -2, 1/4, about there. -1, 1/2, about there. 0, 1, I know is going to be right here. Once you get into the whole numbers, it's a lot easier. 1, 2 is right here. 2, 4, and then 3, 8. All right, and then I'm going to connect all of these points. Notice that it's going to end up being a curve. So it curves upwards like that. All right, because it's going up from left to right, I know that this is a growth exponential function. And then I want to know where the asymptote is as well. Remember that the asymptote is a line that the graph approaches, but it never crosses. So notice that our graph right here is approaching our x-axis, which is y equals 0. It's approaching that line, and it's never actually going to cross that line. So I'm just going to draw that out right there. So our asymptote is y equals 0. So remember, asymptote is where the graph approaches, but it never crosses. Okay, and we're going to go through one more example here of a graph, just so you guys can see another example. All right, so we've got graph f of x equals 3 to the x minus 2. I'm just going to do 5 points this time. So I'm going to do -2, -1, 0, 1, and 2. Remember, you can choose any x values that you want. So these are my x's. Choose any x value that you want. It does not matter. Just make sure it's on your graph. Okay, then I'm going to plug these in for my x. So my function is 3 to the x minus 2. So this will look like 3 to the -2 minus 2. And that's going to end up giving me, I'm going to plug that into my calculator because I cannot do that in my head. That's going to give me a -1.8 repeating. You could write that as a fraction as well. If you did it as a fraction, I think it'd be -1/8/9. Okay, I'm just going to leave it as a decimal because that's what my calculator gave me. All right, so if I plug in -1, I'll have 3 to the -1 minus 2. Plug that into my calculator, it's going to give me a -1.6 repeating. If I plug in 0, so 3 to the 0 minus 2, well, 3 to the 0 gives me 1. 1 minus 2 gives me a -1. 3 to the first power minus 2 for my next one, so 3 minus 2 gives me 1. And then finally, I'll have 3 squared minus 2, so 3 squared gives me 9, minus 2 gives me 7. Okay, so now my points for this one are going to be -2, -1.8 repeating, -1, -1.6 repeating, 0, -1, 1, 1, and then 2, 7. All right, so I'm going to plot all of my points here. So -2, -1.8, I'm guessing is about right there. -1, -1.6 repeating, guessing is close to there. 0, -1, be right there. 1, 1, right there, and then 2, 7. All right, so I'm going to connect all of my points here. All right. Notice that I'm still going up, so from left to right, I'm going up, so this is a growth function. And then I want to look at where my asymptote is. So where is my line, my graph approaching? It's approaching right here, and it looks like it's starting to like taper out, so I know that my asymptote is going to be right there at y equals -2. Remember that your asymptote is a horizontal line, so it's y equals a number. And it goes through that -2, so that's why it's y equals -2. I hope that this helps with graphing. If you need any more help with it, please make sure to log on to IXL. The IXL topic for graphing exponentials is really good to go over. And also, if you need more help, please let your teacher know.